Welcome to the final video on the binomial expansion. I'm your presenter, Aaron Lewis. A quick view of the topic so far, which is the binomial expansion. In lesson 1, we looked at combinations and factorials. In lesson 2, we applied the binomial expansion to some basic questions. In lesson 3, we applied the binomial expansion to some more difficult questions. In lesson 4, we looked at calculating coefficients and indices. And in this lesson, we are applying the binomial expansion to lots and lots of different situations. So in this lesson, we're going to be looking at applying that binomial expansion to lots and lots of different questions, lots of different situations. However, this video is not exhaustive. We do not cover every single style of binomial question in this video. Be sure to look online for more binomial expansion questions and learn the approaches to those questions. So in this lesson, we're going to learn how to apply that binomial expansion to those situations. This will include our knowledge of the binomial expansion, factorials and coefficients. This lesson is suitable for A-level students and the language of this lesson is English. This video is going to be around 30 minutes. And the aim of this lesson is to be able to apply the binomial theorem to other expansions. That's one of the situations. And another situation is going to be approximating values using the binomial theorem. So our first learning objective, applying the binomial theorem to other examples. If you're using resource 1, you should be able to write on it and work with me. So in this situation, we are given the expansion already. And we're asked to use that in this other situation here. And all you need to do is have a look. So, and play the game of what's the same and what's different. So have a quick look. Ask yourself what's the same and what's different. So in this case, what's the same is that we've still got a 1 plus something and the power 4. This time we've got 1 plus something to the power 4. What's different, however, the x has been substituted for y squared. And if that's the case, all we need to do is rewrite the expansion, but instead of writing x, I'm writing y squared. And there we go. There's the substitution. Next thing to do is just to simplify. So 4 lots of y squared there is 4y squared. Here I've got 6 lots of y squared all squared. Remember the 6 here isn't being squared, but the y is, so it's another laws of indices problem. We would multiply the powers. The next one we've got 4 lots of y squared cubed, which is 4y to the power of 6. And the last term then is going to be y to the power of 8. Really nice example where you're given an expansion and you're asked to substitute. Here's your example. Have a go, pause the video and press play when you're ready to see the answer. Okay, and here's the answer. There you go. That example follows mine very nicely. However, there's a little bit less work. So well done if you got it right, and let's move forwards. So after that, I've given you mini quiz 1 to do. Just see if you can use that substitution method. Have a go, get an answer, mark it, reflect on it, and improve. Okay, moving forwards into the next little skill. And this is on resource 2. So this time we've got the first 3 terms, and we've got a binomial, and then we've got a power raised to one of those binomials in ascending powers of x as well. Okay, so if we follow the rule of BIDMAS, which is brackets, indices, multiplication, addition, and subtraction, these two are being multiplied together, and then this one's got an index, so we need to do the index before we do the multiplication. So the first thing I'm going to do is find out what 1 minus 2x to the power of 4 looks like. Now we're working in ascending powers of x, which is good because the 2x is the second term here. So the first thing I need to do is raise 1 to the power of 4. Now we only want the first 3 terms, which is great. I can do that now. 1 to the power of 4 is just 1. Next is going to be 4, choose 1. 1 cubed multiplied by minus 2x. Let's work that out now. Okay, here we go. 4 choose 1 is 4. Multiplied by 4. Multiplied by minus 2 is minus 8. There we go. The next term is 4 choose 2. 1 squared minus 2x all squared. So 4 choose 2 is 6. Multiplied by 1 squared is still 6. Multiplied by minus 2 squared should be positive 24. So what I've got so far is I've got that expansion. So what we're saying is the question is ever so slightly different now. It's now 3 plus x. I'm just going to write it underneath. 3 plus x multiplied by 1 minus 8x plus 24x squared. And there's some more terms that we could find, but it doesn't ask us to. Now we're going to multiply these together. I'm going to go for a grid method. You don't have to. I think for the grid method you can actually see what's going on and you can spot mistakes easier. So I'm going to write the binomial expansion at the top. I'm going to write the other bracket at the side there. And all I'm going to do now is multiply. So 3 lots of 1 is 3. 3 lots of minus 8x is minus 24x. And 3 lots of 24 is 72x squared. 1 lot of x is x. Minus 8 minus 8x multiplied by x is minus 8x squared. And 24x squared multiplied by x is 24x cubed. Now it wants the first 3 terms. So let's have a look what can go together. So you can see a 3 there, it's got no other numbers. Minus 24 x plus x is minus 23x. In terms of x squared, 72 take away 8 is 64. And I know what's the first 3 terms, so I am finished. Here's your question to have a go at. Pause the video and have a go now. Okay, so hopefully you've had a go at that question. The numbers are slightly more complicated than my example, but you should still be able to do that. Well done if you got it right. If you didn't, just reflect, just make sure your arithmetic's fine, and then move forward with the next example. So here we go, my next example. What is the coefficient of x cubed in the expansion of? So what I could do is I could start by, as in the previous example. That is one option. And you feel free to apply that. But I'm going to take a step back and really think. I'm going to start backwards. We know if we expand this binomial, we're going to get a constant here. So we're going to get some sort of number here. We're going to get a value in x here. And we're going to get a value in x squared here. And that's because it's a 1 plus 4x. On the side, I'm going to be multiplying that by x plus 7. So let's think about what we're going to get. Well, down here, we're going to have a number times a number. So that's still going to be a number. This one here is going to be a number multiplied by x. That's going to be a number. Here, I'm going to get an x squared. And that, well, we're not trying to calculate x squared. So we're going to get some x's there. I'm just putting a dot in, by the way, for coefficients. It's not a strict technique. I'm just trying to get you to think. Down here, we're going to get 7 multiplied by... We're going to end up with an x term. Over here, we're going to end up with an x cubed term. And down here, we're going to end up with a x squared term. Now I'm going to continue, because I don't think I've got all the x cubed. So here I would get an x cubed term. And an x cubed term multiplied an x term is going to give us x to the power 4. And there we're going to get an x cubed term there. So I just need to work out the x squared term, the x cubed term, and then multiply them out. So that's my thought experiment done. Now, if you don't like that method or that looks complicated, feel free to use the technique used on the previous example. So I'm just going to erase that and work here first. So I need to find out the x cubed term and the x squared term. So I'm going to find out the x squared term first. So that's going to be 4x all squared multiplied by 1 to the power of 2, and it's going to be 4 choose 2. I'm going to work out what that is. So that's going to be 4 choose 2 is 6 multiplied by 1, which is still 6, multiplied by 16, which I think is 96. Squared there, sorry. And then we're going to find the cubic term. 4 choose 3. And 4x cubed there. So 4 choose 3, I think is 4 as well. 4 times 1 is 4. Multiplied by 4 cubed. So I'm back on my calculator. 4 choose 3, just double checking. Multiply that by 1. Multiply that by 4 cubed, which is 256. X cubed. So I've got an x cubed term and an x squared term. So I only need to multiply those two by the x and the plus 7. So I'm going to use a mini grid this time. 96 x squared, 256 x cubed. So that becomes 96x cubed. This one becomes 256x to the power 4, so we don't need that. This one here becomes 7 times 96. We don't need to work it out because you can see the power is only going to be x squared. 672x squared. And that one down there, that's 256 times 7, which is 1792 x to the power of 3. So I only need to add sort of those two there together. Plus 96. And I get 1888. And that's all I need to write because it asks for the coefficient. It doesn't ask for the term. And I'm finished. Here's your example on the right. Pause the video and have a go now. Okay, so here's the solution. And there you go. If you did it the long way, doesn't matter. I'm just trying to get you guys to spot things. There's mini quiz 2. Have a go. Get your answer. Check, reflect, improve your scores. Okay, so this is our final bunch of examples here. I've got 2 examples for me and 2 examples for you to work on. And this time we're approximating values using the binomial theorem. There's lots and lots of exam questions on this. So first of all, it says find the first 3 terms of 8 minus x and, by choosing a suitable value of x, approximate 7.994 to the power of 4. Now, first of all, I'm going to do what the question asked me to do first, which is to expand 8 minus x to the power of 4. So first of all, that's going to be 8 to the power of 4, whatever that is. Next, we're going to have 4 choose 1, 8 cubed, introduce a minus x value. And then 4 choose 2, 8 squared, minus x squared. So 8 to the power of 4, I'm on the calculator, is 4096. The next term, we've got 4 choose 1, which is 4, multiplied by 8 cubed, multiplied by minus x. That's going to be minus 2048x. The next term is 4 choose 2, which is 6, multiplied by 8 squared, which is 384. And that's positive, because if you square a negative, you end up with a positive. And there we go. So there is my expansion. So I've done the first bit. Now I've got this bit here which says by choosing a suitable value of x. Now this is a technique. I'm going to try and squeeze it in that space there. What you do is you write that. And just look what I've done. We've got something here raised to the power of 4. We've got something here raised to the power of 4. So I've made those two bits equal to each other. Now I'm going to try and find the value of x. Now there's several ways of doing this, but I'm going to go the long way. First thing I'm going to do is add x to both sides. Next thing I'm going to do is subtract 7.994 from both sides, which is 0.006. So now I've got a suitable value for x. So what I'm going to do now is I'm just going to finish the question off. I'm just going to rub that a little bit out there. Just give myself a little bit more space. Hopefully you've learned from my videos how much you need space in maths. Just going to get my pen working again. There we go. There we go. So minus, lost some values there. Now, all you need to do is write 7.994 to the power of 4 underneath. And all we're going to do now is swap every x we can see with 0.06. And it'll be ready to go straight into the calculator there. And we can type that then in the calculator. So 4,096 minus 2,048 lots of 0.006 plus 384 lots of 0.006 squared, which comes out at 4,083.72584. And let's see how close we are. So in my calculator, I'm also typing 7.994 up to the power of 4. And you can see it's very, very, very close. In fact, it's really, really close. Here's your question. Pause the video and have a go now. Okay, here's the solution. And if you typed 1.995 to the power of 5 into your calculator, you can see how close that approximation is. And the more terms we add, the closer it gets. Last example, which is along the same lines. I'm going to do it in exactly the same way. But this time, what I'm going to do, just for fun really, is I'm going to find the value of x first. Doesn't really matter. So 3 minus 4x is equal to 2.992. 3 minus 2.992 will be equal to 4x. So x is going to be equal to 3 minus 2.992. And then we're dividing that by 4. So I get 0.002. Right, let's expand this then. So it's going to be 3 cubed. 3 choose 1. 3 squared minus 4x. Final term that we need. Hopefully you're well practiced with doing the binomial expansion now. 3 cubed is 27. And you might already be thinking, just looking at this question here, 2.992 cubed is going to be close to 27. You can see we've got the 27 out already. So the next term then is going to be 3 choose 1, which is 3, multiplied by 3 squared, multiplied by minus 4, minus 108x. And then the final term here, 3 choose 2, which is 3 again, multiplied by 3, multiplied by minus 4 squared, which is 144. So writing that out, 3 minus 4x cubed is equal to 27 minus 108x plus 144 x squared. So we are missing one term off. So I'm just going to compare that with the question. All we need to do now is substitute all the values of x for 0.002. In my calculator, here we go, 27 minus 108, lots of 0.002, plus 144, 0.002 squared. And we get 26.784576. Let's compare it with the real answer, 2.992 to the power of 3. It's going to be really, really close. Yeah, it's incredibly close. So here's your question. Pause the video, have a go, unpause when you're ready to check. There's the solution. And if you want to check it, or see how close it is, just type in 4.99 to the power of 5. And you see that your answer is fairly close. And I'd like to have a go at mini quiz 3, which is based on those questions there. Just to review our learning aims of this lesson, I'd like you to be able to apply the binomial theorem to other expansions and to be able to approximate values using the binomial theorem. That concludes our series on the binomial expansion. Thank you very much for watching and best of luck with your studies.